In today's journey, we do a couple of water boiling experiments and see how good our BrewPi Remix is at displaying information as we record. But like any good prototype system, everything doesn't go as planned. We were, however, able to figure out a way to get as much information from the Raspberry Pi system to our screen as possible. Starting in the upper left corner, you can see the actual time and date along with CPU and RAM usage. That last number is the current temperature in Celsius of our CPU. So now you can see just how much time is passing in real time during our time manipulations. Up in this corner, we also have the room temperature being recorded, much like the samples down below. Well, at least until we run into our first problem. It seems as though we've lost communication with the Arduinos running the BrewPi Remix program, but not the Raspberry Pi itself, which is weird. As when we also log on to the Raspberry Pi itself, the BrewPi Remixes are working properly there and operating the hot plate itself still. It's just the recording computer itself that is for some reason having a problem getting the data. Eventually, Phil tries to figure out what's going on by logging on to the BrewPi Remixes from the computer itself to find out that for some reason it's trying to find it on the World Wide Web instead of on the local network. How it made this decision, I don't know, but it would explain why home brewers can use these systems but not professional brewers. To short circuit this problem, Phil yanks the cable that connects us to the rest of the network and poof, we got it back. Unfortunately, we hadn't noticed that the camera battery had died during that, and we missed some of the recordings. Personally, I blame Phil. But now that we're back to where things should be, we can start to see the information we were looking for during this experiment, such as identifying the location of cold spots on our hot plate, and testing the accuracy and precision of the BrewPi Remix when spread across multiple styles of Arduinos. However, there is the extra variable that some of our thermal probes came from different suppliers and may be using different parts. We will have to fix that before performing our next experiment. But due to some technical difficulties with the camera this evening, we're going to have to cut this short. Phil does take this time, however, to use the two thermal probes that seem to be working fine together and testing for hot and cold spots across the hot plate for future reference for himself, such as when he comes back the next morning to do his next experiment. We have fully charged both batteries and now we're ready to record testing of the new vessels for brewing the world's smallest beer. When brewing a 10 milliliter beer, it is important to keep in mind that boil off is your worst enemy. And that's what we're testing for today, is how long it will take to boil off 25 milliliters of water from these different vessels. Starting on the left, we have a high form 25 milliliter beaker. In the middle, a low form 25 milliliter beaker. And finally, on the right, a 25 milliliter Erlenmeyer flask. Because each of these vessels expose a different amount of surface area of the water to the air, we expect a different amount of boil off to happen over time. Our hope is to maximize the amount of time to be about 60 minutes so we can do more official brewing at this small scale. Fortunately, the thermal probes are here mostly as a courtesy to test them again, as we can see they're already way off from each other. If you're wondering how we got this information off of the BrewPi to show up on our feed like this, we used OBS to create a scene that had a browser linked directly to the BrewPi itself that we need the data from. We then transformed that into the small amount just around the number, then chroma keyed out the backdrop so that we can see around the numbers. We're going to use a similar technique with the Craft Beer Pi program along with a number of other temperature-based programs to do the same result, to see if we can get quicker and more accurate readings from our thermal probes. Then once we got the system smoothed out, we'll be able to have this information available on all of our videos that we make in the future. We will also have to go back and verify when each of these vessels started to actually boil so that we can see which one actually won. We do believe that the one on the left, the 25 milliliter tall form, is the actual winner, but it was the last one to actually come to a full boil. This is also considered a worst case scenario test, as we are boiling far above how we would actually boil if this was a real beer, therefore minimizing on even more boil off. So Phil isn't that disappointed that we didn't make the full 60-minute mark, as we did get pretty close. We do apologize for how boring some of these videos may be for some people, but this is the process of how we are building our lab, and therefore we would like to share the process with you. Also, if we forgot how we did anything, we can always watch the videos again if we need to rebuild something.